in, the sun always appears above the horizon as well. Always. It's never below. Ever.
So do we think sunsets just don't occur?
And they do occur, but it's atmospheric conditions that cause it.
No. So we should be able to zoom the sun back into sight, into view.
Would you say that the atmosphere is completely transparent, or are there particles in it that may block it out at a distance?
I'm just asking, is that possible?
I'm just letting you know that there's an atmospheric condition under which your whole kind of attempt at an observation is sort of falling short. You're not acknowledging like the true reality of it. You're requesting for something that can't be done because of the particulates in the atmosphere. And we've got, there is footage of literally the circle of the sun not going down below the horizon, but just dimming out effectively, like a dimmer switch, just slowly goes off.
Yeah.
And it just dissipates into the atmosphere rather than being cut off from the bottom up.
Okay, and to be clear, if we went to like a building like the Burj Khalifa, there's no reason to believe the higher on the floor you are, the sooner or later a sunset would appear to you?
Well, if you're higher, you would have a better angular observation to the sun, perhaps. But I'm not sure of that particular condition.
No,
perhaps someone else has a bit of
knowledge. Like
on the logic, you're on the track.
Like on the Burj Khalifa, they actually have to they serve dinner at different times because that's how tall it is, right? So if you're like having they have events, right, and you normally you can have a romantic dinner at sunset. They serve dinner at different times because it's so tall. Sunset appears at different times for different people.
You can literally see it twice if you go up the elevator, right?
Say that again?
Prevails.
Say that again?
You can literally see it twice if you. Sorry, did you say to me or him?
Yeah, exactly. Yeah, you could see it. You could see it twice. If you start at the bottom, see the sunset, go up the elevator, then you look. You can see the sunset happen twice. Yeah.
Also, the whole dimming effect. I'm not really getting how that works on the whole Antarctica thing, but maybe we
don't even need to get to that. We all agree in the flat Earth worldview, we should be able to zoom the sun back in from over the horizon. Correct? We agree. We should be able to do that.
No, absolutely not.
Okay. Why would you not be able to do that?
Because it's reached a limit. There's the horizon is made up of the ground and the sky. Two things: ground, sky, and that's the meeting point is where the ground meets the sky visually. So over a planar surface, let's say you can only see 3 miles of land, 3 miles of ground. That's your ground level, 3 miles, and then you have a sun in the sky, an object in the sky that's moving. Just like a light will lower due to perspective, there's going to be an intersection point at that 3 mile point where the land, where you can't see any further land. It's not the curve of a ball. It's just the end of what you can see of the land is going to create a limit. That's going to create a limit. That's the ground layer. And then you have the sky layer. So as the sky layer.
Wait, but why could you see the further?
Yeah. Please don't interrupt. Please don't interrupt. Don't do that. Just let me finish and then you can speak. Anyway, so you have a ground layer on the ground, then you have the sun in the sky. So that ground layer being at 3 miles is a limit. So when the object moving away from you due to perspective over a planar surface is going to continue to lower, at some point is going to intersect, not physically, but optically, it's going to intersect with that ground layer, the limit of your 3 miles, because that's your limit of your ground layer, and then you have the sky layer. So it's not expected that you would, on a planar surface, that you would be able to pull anything back in if it's gone beyond that limit optically.
But I'm sorry.
You said that was 3 miles? Hold on, really quick. Why can you see the further away sun, but you can only see 3 miles of the ground?
That's what I was going to ask.
Yeah, exactly. Yeah. Why is that the case?
Because it's much higher, and in the sky, it's much higher and further away.
Yeah,
but can you explain why that matters?
Wait, but no, when you have a sunset, you see both the ground and the sun. So why could you still see the sun, but you can't see the ground?
Because the sun is at a much higher distance and much further away, and it's part of the sky layer, which is, in terms of those two parts, the ground and the sky. I'm not sure what you're asking. Like, if the ground is 3 miles and the sun is 3,000 miles, that 3 mile point will intersect with the 3,000 mile high sun. I'm not saying the sun is 3,000. I'm just using it as an example.
You can see 3,000 miles of ground then if the ground was 3,000 miles long.
Nope.
right? On the
Yeah,
flat
no,
Earth.
No. Absolutely not. There's not enough resolvability to see that much ground. You have conditions, you have fog, rain clouds, you have all kinds of atmospheric occlusion that is going to limit what you can see on the ground layer. It's very, very different than the sky layer. So you could see something much, at a much further distance in the sky compared to the ground, right down at the ground level. You mean look up a weather app, visibility 3 miles on this day, 2 miles on that day, sometimes even less than that. So you're not
Right,
going to be
but
able to see very far on the ground compared to the sky. It's dramatically
on
different.
a clear day, though, you're saying the magnitude of refraction would be to the like a magnitude of 1,000, though. The difference
Uh,
between 3,000 miles and 3 miles.
I never
Like,
said the word refraction, so I can't really
No.
respond to that. Somebody else
No,
may
but
have said that.
I'm assuming that was part of the like lighter sky layers or whatever, right? Less dense
No, I
layer.
never said that.
That's
I
what you
never
meant.
used the word
I
refraction.
thought
Maybe someone
that's
else
what you
did.
meant. No, but I thought that's what you meant. Yeah, I know you didn't say that. Maybe I was mistaken. But
okay, so then, just to be clear, we can see the sun because it's in the sky, but there's too many things between us and the ground in front of us that's closer that prevents us from seeing the ground. But we can still see the sun that's behind all of that stuff.
It's not behind anything. It's just above
Well,
the ground.
you just said there's a bunch of weather conditions, right? All of that prevents us from seeing the ground that's 300 miles out, but we can see the sun that's 3,000 miles out, right? Even though it's going to be behind even more of that stuff that's blocking the Earth 300 miles out.
No, because it's up in the
If it-
sky. It's not on the ground layer.
Yeah,
We
exactly.
just
It's
said
like
we just said at a sunset you see both.
yeah, but it's like an optical illusion, dude. It's not really low on the ground. It just appears visually, looks like it is, but it's not.
Okay, so we can zoom it back in, is what you're saying.
To a certain extent.
Okay,
Whenever
so
you do, it always appears above the horizon. The sun doesn't go into the water, right?
I don't know where the sun goes in your view. That's what I'm asking.
Well, it can't. I mean, there's what we're looking across is the surface of the land and the surface of the water. That's it. It's not rocket science.
Yeah, no. So why can't we just zoom the sun back in at night? Like, why do sunsets happen?
I know. Talk to the man upstairs. He designed our eyes.
No, I'm not asking like why can we see sunsets. I'm literally just asking why can't we just zoom in, like get a really great telescope and zoom the sun back into view?
Because it's beyond the optical limit. It's too far away.
so wait,
The ground
this was
layer,
in a
like
vacuum.
if the ground layer is at 3 miles, that's pretty close.
Mm-hmm.
So
Yeah, but like you're saying it's too
Even
far away, but why does it go bottom up, right? Why doesn't it just like shrink out of sight, right? Like when a car drives away from you, like and you can stop seeing the back lights of it. The lights don't disappear from bottom up. They all just shrink out of view and then they become really small and disappear. That's not what happens with the sun. The sun disappears bottom up.
yeah, that would only happen if you had if you could see an infinite distance on the ground, then the sun would never set. But you can't see an infinite distance on the ground. You see 3 miles, 4 miles. So it's going to make a very dramatic cutoff point. You can replicate this on small scales in many ways. You can replicate the bottom-up obstruction. You can also show bottom-up obstruction even without any physical obstruction with just temperature change. Actually, it's been shown in multiple ways.
We agree during sunsets we see a lot further than 300 miles, right? During like the middle of a sunset, we actually see way past that.
Yeah, it would only shrink to a tiny dot and it would never set if you could see forever. If there was no atmosphere, no conditions, if you could see forever on the ground layer as well. Like the thing is, you're not going to be able to see forever on the ground. Like think about the angle. If you're 6 feet above the ground, the angle from your eyes to the horizon to the ground is very, very small. It's a very, very tiny angle. So you're not going to be able to take in, like you're not going to be able to see, thousands and thousands of miles of ground with all the detail. I mean, the furthest world record
the
photography
sun.
is like 300 miles. It's like the
With
furthest
the
photography, but
why can we see the sun then? Why does it disappear bottom up? Why doesn't it just shrink out of our view?
okay, well, that's what I'm just describing. So if there was no atmosphere, if there was nothing, it never would set. It would go to a tiny little dot. That is correct. The reason that doesn't happen is because you have a ground layer that is much closer, like 3 miles. So you have a very large object in the sky that is moving away from you and setting due to perspective, and then you have just 3 miles on the ground. Now, if you could see 400 million miles on the ground, then yeah, the sun wouldn't set. It would just it would just get closer and closer to the horizon. It would never set. But the fact that you only see 3 miles, now you have a 3-mile circle around you, is going to set not a physical limit. It's not a physical limit of a ball, but it is setting an optical limit where the sun will be dramatically obscured due to that limit. And you can replicate this, like I said, on small scales. It's quite easy to replicate.
Just get a really strong telescope and let's just pull the sun back over the horizon at a sunset. That would be a great project to do. Let's do that.
Okay, nobody's claiming that, so I don't know if you want to do that. I guess do what you'd like, but I don't think anyone's claiming that at the moment. There are some cases that you can go higher and see the sun, and there's some cases depending on in terms of zooming. But if it's beyond that optical limit, it will not be able to be brought back. So to say that would just be strawmanning or a conflation of what happens over a planar surface.
Sun back in. It's not an optical limit. I'll repeat the question. So we can't zoom the sun back in. It's not an optical limit.
You just said two contradictory things. Yeah, if it's beyond that optical limit point of the ground layer, you will not be able to zoom it back in unless you can see further on the ground, unless you can try to expand that.
If we get a telescope, yeah, exactly. If we get a telescope and we just go out at like a sunset, let's zoom the sun back in after the sun goes completely below the horizon. We increase our optical limit. We just see further.
Absolutely not. That's not what that does. Yeah, a telescope just allows you to see more detail, more angular resolution. It does not allow you to see further in that way. Not in that way. It's not going to extend the ground layer.
Okay. A telescope doesn't allow you to see further. We're gonna stand on that position for this.
No, I'm going to clarify very precisely what I mean by that. What I mean by that is that it does not allow. Okay, there's two things with that. It will allow you to see further in terms of the fact that you can magnify. So, like for example, it's like two things at the same time. So let me see if I can describe this. So if you have an optical limit, let's say you have the ground layer limit at 5 miles. But let's say the last 2 miles of that you can't see with very much detail. If you were to bring in a telescope from mile 3 to 5, now you would see a lot more detail. So in that way, you could say that you're seeing farther because you're getting more detail of that 3 to 5 mile point. So in that way, it allows you, if you want to say quote unquote see further, it allows you to get more detail. But it's not going to let you. It's not going to allow you to see past the 5 miles. That's not.
So I thought it's like if you couldn't see something even more than 5 miles, now you start to see it a little fuzzy. 5 miles becomes clear, and then super close to you becomes super clear, right? So it increases your optical limit. Is that not how? Sorry, I might not get how telescopes work.
I mean, I would say it just increases your discernment of what you're looking at. It's not increasing your optical limit.
Oh, so it doesn't let you see further. Telescopes don't do that.
It increases your discernment.
Yeah, so would you say it lets you see more details because it increases the optical resolution? Like, would we say that or no? That's not what telescopes do.
I just got in. What's the topic?
I think I beat flat Earth.
Oh,
You tried.
how? What happened?
You're just repeating
I
yourself.
just want to ask a
questions.
really easy question about sunset. And in the flat Earth view, we should be able to zoom sunsets back in over the horizon
Nobody
by
said
using
that.
really strong telescopes. We can increase our optical limit, right?
Yeah, nobody said that, dude. You have to if you're gonna have this discussion with it being genuine, you have to actually go off what people say. If you're just gonna straw man and use tactics and
so it's not an optical limit then. The sun doesn't disappear because of an optical limit. There's some actual barrier there. There's a physical barrier that stops us from seeing it. It's not an optical limit.
All right, nobody said that either. Are you just purposefully being deceptive now, or what are you doing?
No, I'm curious. What's stopping us from seeing the sun at night?
I mean, wouldn't it be like perspective?
Yeah,
Like-
so if it's perspective, you're saying, well, our optical resolution is not good enough to see the sun at night. So if we got a really strong telescope, we should just be able to bring that bad boy back into our field of view.
Let me ask you, if you
Mm.
go too far from a light source, will you be able to still see it?
Yeah, we can. We can. That's actually why we can
Really?
see stars. Yeah, as long as the light hits our eyes, we can see it. As long as there's nothing in between us.
Yeah, well, whatever is further than you can see it. Then you have
That's
don't you
not a
have light?
thing.
Oh, really? So the light doesn't have light attenuation?
What do you mean by that?
Donnie
So you
knows
don't
what
know
that
what
is.
it means.
Doubt it. He's
Well,
pretty-
as far as I understand it, as long as the light hits our eyes, we could see the thing.
So like the light doesn't follow the inverse square law or anything?
Yeah, so light expands, or basically the waves expand, but that doesn't have an issue. As long as the light hits our eyes, we can still see the thing. It will just be in less detail.
You're saying if the light's hitting your eye, you can see it,
That's what seeing
right?
is. Yeah, yeah,
Right. So if the light doesn't hit your eye, then you're not seeing it.
exactly. Yeah.
And
So what
and
stops the light from the sun hitting our eyes? What stops that?
A lot of things.
I would say it's part of its perspective. Things converge into the horizon the further out they go from you.
We should be able to take a really strong telescope, just bring that bad boy back into view.
Yeah, learn about light attenuation.
Well, then we also got the topography of the surface.
Okay, so during a sunset, could you explain that then? Can you?
There's
Yeah.
multiple factors at once. Can you comprehend that?
Yeah.
Dude, we
so
made a light disappear in a warehouse. It had line of sight on the light, and we made the light disappear without moving anything.
Did you turn the
Pebbles in
light
the
off?
pond.
Direct line of sight. All that was changed was temperature. The door was opened in the warehouse that brought a different temperature change in, completely obscured it from the bottom up with nothing physical in the way whatsoever. You could verify that.
Huh.
It was only over like 40 feet or whatever. You could absolutely verify there's nothing physical in between, and it shows bottom up
True.
obstruction. Sky
Well, in
free.
your-
Yeah. Sky
In
free.
your worldview, we could just use the sun to do that. Very large
Well,
light,
how-
no physical barrier in between us.
How
Right?
far away do you think you could see a single candle with the naked
don't-
eye?
If there was nothing in between you and the candle, like no
Nothing
air,
in between you and the candle but distance.
oh, you would just be able to see it forever. Then, if it was just black but the candle, you'd be able to see it from any distance.
Have you tried any of these to confirm that that's the case?
It's just simple logic. What would stop you from seeing the candle? What would stop
So
you
the
from
answer is
seeing the
no.
light?
Over
So you've never
distance,
tried this.
No, I'm telling you, that's literally what a star is. That's what a sun is. What would stop you from seeing the light?
You're saying a star is a single candle?
No. I'm saying a star is light. There's nothing between us and a star. We could see stars
We're
across the
talking about
galaxy.
we're talking about a specific amount of light though. I'm talking about
Yes.
one candle watt.
The strength of the
Yeah.
light matters here too. A star is way more powerful than a candle, dude.
Okay, and the stars are way, way further than a candle is.
Yeah, it's way more powerful to make up for that though.
Yeah, okay, it may be way more powerful. What would stop you from seeing the light?
There's different factors.
No, if
Well,
there's nothing in between you and a candle, and the candle's infinitely far away from you, what would
There's
stop
a
you
lot
from
of
seeing the
things
candle?
between you.
Well, sir, the inverse square law states that the brightness decreases with the distance squared.
Yeah, so it might
There's
the brightness may
atmosphere, there's topography, there's light diverging over distance. There's so
Sure.
many reasons here.
So Dieslow gave an example with a candle, nothing in between you and the candle. Now the brightness of the candle may decrease, but assuming that you have a purely black background and you have a light, our eyes would still be able to distinguish the difference, right? It would never dim to a degree where we think it's black, unless you have really, really bad, eyes. So I'm asking again, what would stop
So,
the
I mean,
light
a
from
the
hitting your
atmosphere
eyes?
and
I mean,
the
a
topography
simple
and
Google
refraction.
search would have told you that a typical candle is seen about 1.6 miles on a clear day.
Oh, there's
And
atmosphere,
this
right?
this distance assumes there's no obstructions like fog.
Yeah, but there's still the atmosphere, right?
Yeah, you're always going to deal with the
Yes,
atmosphere.
atmosphere,
Even if you're
topography.
so there are
making
things
hello. Yeah, I'm right in the middle of speaking. Yeah, you're always going to deal with atmosphere, even if you're making celestial observations. There's going to be an amount of atmosphere you're going to be viewing through. Go ahead.
Oh yeah. So again, this just we can do it with a candle. We can do it with the sun. In your worldview, there's atmosphere, but it's just going to be no matter where you are on the Earth. If it's a flat Earth or a round Earth, you can still see the sun during the day. Why can't you see it at night?
I mean, did you not just hear my answer to you? Like if a single candle isn't going to be viewed at an infinite distance, right? Only 1.6 miles on a clear day, then what makes you think the sun is going to do anything different? Just because the intensity is stronger?
No, because the reason we can't see the sun at night is because we turn around and then we're on the other side of it. That's why
I
think it happens.
understand.
But
I
by your
understand your worldview.
explanation, yeah, but with your candle explanation, the candle would never disappear bottom up, right? It would just dim out of our sight. So why does
have you done this?
during a sunset? Why does during
Have
a
you done
sunset?
this?
Yeah, I've seen cars go far enough away where I can no longer see the light. It doesn't go bottom up. It just dims out of my vision. So you
It
have to
doesn't sound like
explain.
you've done this.
Okay, well, I just told you that I did it. We've all seen cars drive away from us, right?
I mean, at a far enough distance to where it's going to disappear from your angular view, your angular resolution.
Bottom up. Yeah, never disappears bottom up,
You've
right? It
never
just
seen
dims out
that.
of
The
your sight.
topography wouldn't allow you to see that.
Yeah, I mean, unless you've done that, I don't know.
Yeah, I just said I did.
I think you're making assumptions.
He hasn't done that.
Cool. I've never seen a car drive away.
Yeah,
from
we just told you we could make a light disappear.
No,
Sure.
yeah.
40 feet around 40 feet.
True. Yeah. Again,
Bottom
like I said,
up.
but okay.
Bottom obstruction.
Cool. Sure. So let's see
On a
you
flat
explain
surface.
that. Yes, let's see you explain that with the sun.
What more needs to be said? Like I've already given you plenty of enough answers.
Sure. So you said yes.
I said perspective. I said the fact that light doesn't carry on indefinitely as you would presume it to.
Sure. So two things. If it's perspective, then we could just zoom it back in. And if it's because of the inverse square law, it would never disappear bottom up. It would just dim out of our vision.
You ever heard of the Rayleigh criterion?
No.
I'm sure you haven't.
Okay. So can we explain why the sun
You're-
disappears bottom up
You're
if it's
applying
just
all
because
those things separately rather than together.
but I'm just asking why you explain the sun disappears bottom up if it's
but
because
you're
it goes too
putting
far
the
away.
reasons in a vacuum when all of those things can be occurring at the same time.
Okay, so if it's angular, if we use a telescope, your explanation for the sun disappearing is it actually doesn't disappear bottom up. It actually dims out of our sight if we look through a telescope?
It depends, dude.
It
depends on what's affecting it. If you can tell me what's affecting it, then we can narrow it down, but you can't tell me that.
Well, the reason the sun disappears in actuality is because we're on the other side of we're spun. Yeah, but your reasonings are because it dims out of our sight. That doesn't explain why it goes bottom up.
We know this to be true. There's multiple reasons why light would not reach our eyes.
I agree, yeah.
Okay,
None of them apply to the
it's up
sun.
to you to prove what that reason is. I don't have to.
Sure, I just did. So the reason, and I gave you an example with the Burj Khalifa too, right? So if you go on the Burj Khalifa, you could experience the sunset twice for the exact reason.
Height affects your resolution to the light, yeah. We've already admitted.
I know. So, but we also using a telescope should bring back the sun over, right?
Again,
on a flat plane.
telescope just increases your discernment. It doesn't make you see further.
Okay. That's a great position to die on. That's a great hill to die on. Anyone else?
No, you guys admitted this too. You guys said we see infinitely. So it's not much different from what you're saying.
Yeah, I'm saying you see infinitely,
if you're
but
saying we see
things
infinitely,
dim
then
out.
a telescope wouldn't increase your view on infinite, would it?
Yeah, but things don't. The reason we don't see things. Well, I'm literally explaining right now. The reason we don't see things is because they dim out of our sight. They don't go bottom up. The sun goes bottom up. It doesn't dim out of our sight.
So if I can see infinitely, would a telescope increase my infinite sight?
It would make it more detailed.
Exactly, your discernment. That's what I've been saying the whole time.
Yeah, but it would never make things that are blocked by another thing come into view.
Did anybody say that?
No, that's what you're saying the sun does. You're saying the sun dims out of our sight.
We're not saying it's
No.
blocked.
Exactly. I know. Exactly. Yeah, exactly. You're not saying it's blocked. You're saying it dims out of our sight. So I'm saying with a really strong telescope, we should be able to bring it back.
Bring it back
We
from
agree.
what?
Hmm?
You're saying bring it back from
We
what?
should be able to see it more detailed, clearer.
Why?
Because you think the reason the sun disappears isn't because it's being blocked, it's because of the angular resolution.
I do? Or who does?
You do.
So we're gonna leave out the other factors, or are we gonna keep putting things in a vacuum? I don't get it.
I thought you thought vacuums don't exist, but we can go through all the things that would prevent you from seeing something and
Well,
see if
that's
they.
my whole point. If you're gonna keep putting it in a non-existent vacuum, you're gonna
We
keep
could do
making
two.
your
We could
point.
do two things at once. I'll even give you this. I'll let you go to the top of the Burj Khalifa on a perfectly clear day with the strongest telescope you have, and I want to see if you can look at the sun for 24 hours.
My eyes would probably hurt. I don't think I want to do that.
Oh, you can use like one of the blockings, one of the like shields.
24 hours? What?
Yeah. You don't even need to look at it. You can just put a camera right over the telescope.
Did anyone
You don't
claim
even
they
do
would
it.
see the sun for 24 hours at that height? I'm not sure they did.
Oh, so why would you not see the sun?
I'm not
There's
sure who you're
no.
arguing against.
Again, why wouldn't you see the sun then, right? Because there's no obstruction from the air. There's no obstruction from land.
Says who?
Says you.
I didn't say that. You just said it for me.
But do you want to go to the top of Mount Everest, the highest point on Earth?
Do I want to? No.
I know, but like, do you want to do this? We can do this experiment in a plane. Do we want to try in a plane?
I'll let you lead, dude. Let's buy us
All right, so
tickets.
we
Let's
can
do it.
we can do
Buy
it in
us
a plane.
tickets. Yeah, I want to
Sure.
do it. Let's do it. Buy the
Oh, I'm not
tickets.
gonna buy you tickets. I've assumed you've been on a
Okay,
plane before.
well,
You've
then
seen the
ask me
sunset on
a
a plane.
question. Then ask me a
What?
question if you're not going to pay for it.
No, I'm asking you. You've been on a plane and if you've seen a sunset before.
I've been on a plane.
Have you seen a sunset while you're on that plane?
No, I haven't.
Has anyone in this chat seen a sunset while they're on a plane? It was fun, guys.
Yep.
Well, thank
So,
goodness.
so sunset on the plane is gonna prove the Earth is wet. This guy's
Yeah, I think he's got a. Well, thank
So
goodness.
so sunset on the plane is gonna prove the Earth is wet. This guy's
Yeah, I think he's got a little bit more studying to do.
Yeah.
It's like someone just entered into the conversation without trying to attempt to steel man the other explanations. It's okay.
What was the question about sunset on a plane?
We don't know. He didn't. He left.
I don't
before
know.
could
He didn't
elaborate.
elaborate. Has anybody seen a sunset on a plane?
Yes.
Okay, now what?
I've actually seen sunset before I took off and then seen it again after I took off.
So now.
Okay, now what? That's pretty cool. That's actually pretty awesome. But now what? What does that tell you, Left Lane?
Well, you know what it tells me.
No, I don't.
It's just a geometric issue that
So you were flying for 12 hours, or
you see the sunset from the ground and then you take off and you get higher. Geometrically, it allows you to see further. It moves the horizon away from you, and you can see further. See more of the surface, but also allows you to see the sun again before, and then it'll set again.
Yeah, Left Lane. I just tagged you in the live stream chat. It was a pilot. I think the channel is called Excel Jet, and it's labeled Sunrise Under the Clouds at FL 280. Have you seen that video?
I'm not sure. I'd have to look at it.
Okay, no rush, no pressure. Everyone else, you can take a look at it if you haven't seen that observation before.
Oh yeah, I see the thumbnail. Yeah, it's pretty cool. See, for me, that means the sun has to be below those clouds to be shining through them like that.
Yeah, so some people believe observations like this would be evidence for the biblical flat Earth, so the local sun and moon under the firmament. So the sun would be below the clouds.
I wouldn't buy that one because you're saying that people can just fly into the sun.
Well, I believe it would. The sun would change in elevation as it traverses the plane.
But like where it is in this like what the claim this video is making is that this plane would be able to fly into that sun.
Yeah, and have you seen? I'm going to post you. I'll take you specifically, and I'm just curious if you've seen the other video that I'm going to post. It's an observation made by two people with two cameras at a beach. No, this is an older video. I'm almost certain you guys have seen it, but still, I'm sure some others haven't.
Yeah, I've seen these clips.
Yeah, those are kind of crazy looking.
Yeah, it's almost as if the
Logic.
creator... Oh, go ahead, Leslie.
Go ahead. No, you
Okay.
finish. Go ahead.
Thank you. It's almost as if the creator knew ahead of time that these two people were going to go to the beach that morning and make that observation. So he made this like, it looks like as if it's a hand holding the sun. It's like as if he's like, here you go. It's right in my hand for you. I'm laying it out for you. But thanks, Leslie. Go ahead.
But the implications of like the one in the clouds, I mean, it looks like the sun's in the clouds, right? Below clouds and above another. We would encounter that in airplanes if they were in that proximity, you know?
Yeah, I think a more interesting observation for one of these videos would see something disappearing behind it.